Please give a welcome to Jose.
Hey. Um, okay. Okay. So first about me, I'm Jose La Pena from Igalia. My experience relevant here is mostly because I work on several downstreams based on WebKit and Chromium. Examples, a recent example like LG WebOS Web Application Manager or the port to AGL of WAM. Okay, so the problem we are going to talk about today is about the challenges about maintaining a downstream of Chromium, the problems we find, and the strategies we can use to minimize those problems. There was a previous edition of this talk on the Igalia Web Engines Hackfest this summer. It was kind of a breakout session where we would have people from different downstreams presenting themselves, talking about the problems they have. The audience was different, and this time there are more Chromium maintainers around, maybe more decision makers, I hope. So yeah, let's see what we can get with this. Okay, so the main goals of this talk are basically first, sharing a bit how things are done in downstreams, sharing those problems people are facing, focusing. The focus in this case is on how can upstream help to make things easier for downstreams. Okay, so I'm going to present the topics, the highlights on the discussion that happened on the Web Engines Hackfest, and then I will open turns for people that want to share experience if they want, or problems, or possible solutions. Okay, so this is the agenda for the topics we are going to present. It's these are the list of areas where I'm going to present different slides. Okay, so first, the question is why people do downstream instead of just picking upstream Chromium. That could be enough for many cases, but not for all. Okay, one of them is the hardware and OS adaptation. So if we want to have a browser with that is quite tailored to the platform, to the device, to even the graphics backend. Okay, so as an example, Ocean Waylands, that is now something that is happening upstream and is working upstream. It started as a downstream project. It started as a way to, okay, we know we need in our OS using Wayland, we need to have Chromium working. How do we do that? And there was an effort. It was a large target, but it was not an official target for Chromium at that time. There are adaptations, different GPUs, maybe hardware acceleration for different devices, different audio backends. Yeah, Chrome offers nowadays awesome for OS and platform abstraction. There are different abstractions available for media, for audio, for many pieces of the systems. So it's nice, but yeah, sometimes you basically need the adaptation to be available, and that's one of the reasons for having a downstream. Then there's another one that is more product-like thing, like it's about differentiation. Like, okay, I want my browser to be better than any other because we have this feature or whatever. So some features are expected to be downstream because these people doing differentiation want to be their own thing. I mean, so there's also the part about branding adaptation because this product needs to have its own recognizable brands and even integrate properly with other components of the platform. Well, we have examples about it like Brave, Vivaldi, Microsoft Edge, like different features, different browsers, they are different, and there's the need to have a differentiation. Another reason for having downstreams is the support for hybrid application. Like, okay, we have application that is native, but it embeds web contents. An example of this could be Electron or CF. Okay, then another problem that is quite important from my experience on downstream projects is about their growth strategy. You have a downstream, you want to keep up with the work that is happening upstream because you want to have all the security, all the new features, and you don't want to have a browser for 5 years ago web. You want the browser for for nowadays web. So typically things that happen in this kind of discussion, you can have a series of patches that are based on top of each new version. You can use Git merge for doing that, using Git for doing that integration. Or there's often also the thing about maintaining when there are files that you cannot reuse directly, you can copy the contents and start writing on them. And that has its own problems because you cannot catch up automatically with the upstream changes. This is the kind of things that when maintaining this time they come often to the table. Then there's the thing about timing, and it's like, okay, we want to be as close as possible to upstream. So when do we move to a new baseline? And are we doing daily merges, weekly, something automated that is even more frequent, every major release or something else? Most frequent thing is doing upgrades on major releases, but it's not the only thing, and it could be like even every year, every few months. There are many different ways to approach this. Because rebasing is expensive, it needs resources, and if you want to catch up, it's something that needs to be planned, and it's a continuous effort. Okay, so these are a few common ideas that were thrown in this Web Engines Hackfest about how people are doing things that work right for them. One of the clear things was that it is better to rebase often because you avoid huge deltas. And the problem with huge deltas is that sometimes you rebase and the complexity, even the mind complexity of having to deal with all the changes in different parts of Chromium that are, you need the knowledge to understand how to do that. And if you do rebase often, you can react earlier to the problems and you can spread the effort a long time. Still, there are some refactors that are going to still impact in a short time frame, but they are not so much. Another one is quite obvious, like as much if you automate, you can rebase more often because you just rebase more or less automatically. Then you can detect automatically if there's a regression. It's not about it's not only about rebasing automatically. It's more about passing QA automatically, so you can detect that your functionality in your browser is still okay. Another strategy is using multiple levels of upstream, downstreams. So you could have maybe one layer that is very close to upstream, but doesn't have all the functionality, and then you delay things that are more complex, but that are more downstream specific to deal with those in a downstream of that downstream that you can use for not having the effort of upgrading so much in the paths that do not have so much conflict problems with upstream. And then another strategy that was commented there was basically having all the features that compose the downstream in different branches, and then compose those different branches in the final upgrade, the final rebase. Like this is great because you can have different teams working on different features and that know exactly how these features conflict usually, and to keep up with the news on upstream, the new refactors that could affect them, and they don't need to know so much about all the changes. Okay, and then there was discussion about how Chromium could, upstream could help more downstreams. And there was the idea that, okay, what would you as upstream? It's a kind of wish list or list for Santa Chrome. Okay, what could you give it to me to make things easier? Some answers from the web interface discussions were one of them is basically very clear, and it's that if it is easier to reduce on adapt, better refactors, better componentization, so we could pick more things from upstream that are usually better. A very clear example of this is that there's a lot of code in / Chrome that may be useful for other browsers, but as it is in Chrome, maybe you cannot reuse that because you are not taking all Chrome. You are working on content API level and then adding several components. So this helps usually when there's something that can be useful for module browsers, it's better to have it in components than in Chrome directory, and well, as a component that is reusable. Improving extensibility in general is better, like more abstractions for very specific adaptations. There was this other one is interesting. It's about more about how the community works, and there was the idea that it would be nice to have downstream advocates in the Chrome community project. Basically, the idea is having somebody adopting the role of upstream Chrome, talking to downstream projects, a contact point where people will say, okay, we are having this problem, and how things could improve. There, we already have the embedders mailing list. It's not working too much right now because there's not much activity. It's something to blame to both sides, I guess, to downstreams and to upstream, like there's not a lot of conversation there. But it will be something that it will be good to recover or to make it work. Yeah, basically the other thing is that in the same direction, like if we have more explicit channels, like, okay, we have this channel, these people that are going to be good contact points for downstream concerns, that would be great. As an example, it's very easy that sometimes feature gets wiped out in upstream Chromium because apparently nobody uses that feature, and downstream are really using that. These are the kind of things that they will usually say, okay, come on, we have a problem because of that. Okay, some typical problems. Okay, the biggest problem is still rebase conflicts. When I talk here about rebase conflicts, I'm not talking only about the typical JIT rebase conflict. It's also about functional conflict. Like your rebase, apparently nothing happens, everything is right, and then you build and it is right, and then you run and everything is broken. This is kind of this is something that is fixed with automation, things like that, but still it's a problem for downstreams. So yeah, it's a problem. There are many fixes for that, many workarounds, but it's the kind of thing that is usually problematic. Okay, another typical problem, it's well known that Chrome provides almost no API stability. There's one reason for that. Well, there are several reasons, but I think the more known is that it allows to move faster, to evolve faster, to take decisions, taking more like the Chrome as a whole. But some components move more than others. So basically, one example, usually many downstreams will build on top of Content API. That's an API that still doesn't have like stability, but it's not a big deal because it doesn't change so much apart from when there are like big refactors, like modifications, that were different. But usually you have a layer that you can rebase easily and with not so much effort. Bigger changes that affect downstream, obviously the C++ and coding standards. Every time there's a thing like that, you need to actually, the good thing would be like the downstream would adapt to keep with the very same baseline of the coding standards. And well, they have the changes, yeah, massive refactors like modification is very clear. An example where things move around, the IPC changes, things like that. Those were problematic for downstream usually. Okay, and this is the thing that I talked before. Okay, you have a feature, and then Chrome drops that feature. Then what happens? Basically, in downstreams, you have several strategies. One is reverting the downstream, reverting the commits that drop that feature downstream and keep maintaining downstream. That's usually quite problematic because as the architecture changes, the effort you need to do is better and is worse. And it kicks, it's a problem also for one of the main reasons why downstreams use Chrome and not anything else. And is that, okay, you want to reduce something that is moving, the project that is working very well for a web engine, so you don't want to lose that part. Another way is basically having a path to drop that feature downstream. So you need to plan, you maybe have legacy requirements for that you need to keep in the downstream for some time. And then there's the third one that is trying to make a case for upstream to reland the feature because, okay, this was not this was something useful. Maybe we could make it a case. An example for that is MathML, that in the end, it had several approaches, and in the end, it's now a successful case upstream again. Okay, usually it's a problem, but yeah. Sometimes it's also a symptom that downstream do not communicate very well how they are using Chromium and why these kind of features could be important for them. Okay, another problem is, okay, Chrome adds new features. That's good. With abstractions for upstream, that's still good. But those abstractions need to be implemented for these downstream. So it's an effort that, okay, we need to implement PWA. And PWA, for all the downstreams I know, it's being really, really complex to integrate because it's quite tailored to the OS and to the user experience. So yeah, it's a great feature. It's great for the web, but it's a problem. It has been a problem because it's not simple. Okay, then another discussion topic was about the downstream size. So yeah, basically it was the consideration about it is important to keep track of how big your delta is with upstream, not only the regular Git delta, but the modifying delta. That is the delta that affects existing files upstream, because your files that are completely new, they are not going to conflict in any merge, but the modifying delta is usually complicated. If anybody wants to say about anything about how they track things for delta, that's let's hear them later. So yeah, the other thing is that how much you build on top of Chromium. On one side, browsers are usually very, very big. Web runtimes for hybrid applications are smaller because you don't take so many pieces for a browser UI. Yeah, then there's the layers you use in Chrome. You can use Content API, being something very similar to Content Cell, maybe, or you take several components, or basically you directly depend on Chrome and you maintain everything on top of what is already existing. The bigger the path you reduce the Chromium, independently, the bigger the problems you are going to have with rebases because you have dependencies also. Okay, so that's it for what we discussed that day. For the ideas we wanted to talk about here. So we are now for some open discussion. If anybody wants to tell, main focus would be downstream maintainers. Well, what about your problems? What tell about your happy stories and sad stories? Yeah, what can Chrome do as a project, as a community, to help better?
All right, any questions? Have one from the audience?
Yeah, hey there. Is this working? Okay, great. Hey, I'm Brian Clifton. I'm with Brave, and just wanted to give some experience and happy and sad stories, maybe. So yeah, we've been maintaining a Chromium fork for a while, and so it started with Electron, and so we were doing that, and that was definitely a lot of sad times going back before Chromium 54 and the GYP and versus GN. So the recent times have been pretty happy, and so we have a strategy with we have patches that we'll have on top of Chromium, and then we have kind of a mirror directory structure under Brave where it's like Chromium source and then the same path. And those we'll have our GN files basically replace when it GN's processing, it's going to run ours instead of the ones at the root path. And so that's where we do our replacements, and it's been pretty lightweight. We've been able to keep up pretty easily. We have basically 3 people, and that's it. For a long time, it was just one guy, and there were a lot of folks helping and supporting him. But yeah, and so there hasn't been any bad upgrades recently. I think some of the stuff with Polymer has been a little bit interesting, and so my colleague Pete had kind of devised a strategy for some of the Polymer patching on the settings pages where it's using behaviors, and we can kind of inject a behavior on the settings page versus a patch, which gets a little bit difficult, especially when it gets in the shadow DOMs. Yeah, that's just some interesting thoughts, I guess. It's been pretty good times.
How far are you from the main? Like how many days?
Well, like there was a new stable release today, so we pushed one today too. So we can get the small ones out real quick. We're automated on those. And then the bigger releases, though, we get those out the same day too. Typically the same day. Sometimes we have like a 1-day slip or something if it's a holiday, or but yeah, we're pretty even there. Like one of the sad stories, I guess, is it's hard to know when there's going to be like a release, especially if there's like a CVE or something like that. So I just go to the page for the Chromium releases, and it will have like, if they're rolling out currently, it'll say what percentage. I just, pull up DevTools, looked at what REST URLs are being hit, and I wrote a job that just diffs the thing. And when I see a response, I know, okay, they did a release. And that's like, it would be great to get more info. I've asked about that in the Chromium Slack, and I don't think there's anything currently available. So that's just something that would be cool.
I'll add something onto that. Also work at Brave. I mean, just hearing about how many different forks there are and downstreams there are, it might be interesting to, share tooling around that, share techniques for patching, techniques like, as Brian was mentioning, for injecting into Polymer pages, things like that, modifying Polymer pages, all that kind of stuff. I don't know if anyone's, maybe you guys have more of an overview of all the different techniques different browser companies are using and how different they are, or maybe how much could be shared between all the downstream efforts, because it seems like we are maybe reproducing the same kind of tools to do patching, rebasing, and injection, and redirects, CZ redirects and stuff. Yeah, so yeah, could be an interesting way to go.
At least from my side, it's exactly we have contact with many downstreams. The problems are common. The solutions may vary a lot, but the thing is exactly like this. Like maybe there's more opportunity for using solutions for adapting, because in the end the problems in many cases are quite similar. There's not a lot of overlapping in all the cases, but at least for rebasing strategy there is. For hardware adaptation, things may vary more, and they are quite more specific. But for rebasing effort is definitely something like same tools could help many ports.
The last thing I'll have is just with the rebasing too. Like if anybody, like to Pete's point, if anybody wants to approach us, hit us up. We'd love to talk and share more. Everything we do is all on GitHub, and that we operate on GitHub. So all the issue tracking, everything. And so one of the sad stories is, basically our patching that where I mentioned the overrides and we, try to mirror the structure. Sometimes if those don't apply, then we can have a compilation succeed and it just didn't apply that patch. And so that's definitely a sad story. So we do have a tool, like some tooling we've written that tries to detect that those things didn't apply or there's no, if you try to subclass, there's no match for that or whatever, something like that. So yeah, we have more tooling. It'd be cool to share some of that and have already talked with some people. It's been great. So looking at browser company over there.
Any other questions?
Yeah, I have one comment about the security patches. So Brian mentioned this, but it's quite hard to keep users secure because we have to play catch up with Chrome most of the time because we know the version number that's going to be shipped as a security respin when it ships. We don't know in advance. So every Tuesday we are just waiting, refreshing the page, waiting to know the version number. And as soon as we know, we start updating the product. And I talked about this with some TPMs from Chrome. I think it would be really nice to know one day in advance which version is going to be sent to QA for the release the next day, just from a security perspective, it would be nice to be able to update all the browsers at once immediately when we disclose something like the WebP vulnerability that happened a few weeks ago. We usually do it within 24 hours, but it would be nice to know in advance so we can just all release security patches at the same time in all the browsers and just shut the door for these exploits. So I don't know I would love to drive this process and to work with someone on this because I think it could be good from a security perspective.
Hi, Tomasz Szydowski here from Viewed/Xperi. So I can share some stories because we maintain a TV-focused fork of Chromium, essentially. And so because it's a TV and embedded focused fork, there isn't much overlap in the product goals between this and Chrome for desktop. So for us, most any successful upstreaming is a success. So we are always happy when we can get rid of some of our, for example, GCC patches or lib std/c++ patches. We often have different people make the fix, different people upstream because of time concerns. And as a sad story, we joke around that it has been 0 days since the last major base refactor that forces people to play catch up. And one observation we've had is that rebasing not often enough can lead to missing the transition period where you have both the old and new APIs and some helpers that let you not switch everything all at once. So this was something we learned the hard way. It's better now, and in fact, the recent change to a 4-week release cycle has made things a lot better because essentially rebasing to stable Chrome lets us have a fairly comfortable cycle these days. Yeah, thanks.
Thank you. Another one, maybe we have 5 minutes, right? Yeah. We have time for more if anybody wants to say their stories. If not, we can finish now. Okay, so yeah, thank you. It was nice to have to put this here. Thank you. Bye-bye.
Thank you, Jose.